Hello everyone and welcome back. In this lesson, we're going to go through some of the core features of geodatabases in general so that you know how you can organize your data and ensure its integrity. Specifically, I'll show you how to use feature data sets to both organize your data but also ensure high integrity of the data, how to use relationship classes to make relates more permanent, how to add attachments to your features so you could store images in your database, and then also how to compact your database to get some space back if you've deleted information. Okay, so let's start out with a featured data set. Think of featured data sets as folders that aren't primarily for organizational purposes, but have a side benefit of it, and are really there to enforce projection and coordinate system constraints on your data, to make sure that your data keeps the same integrity across a project. So if I create a new featured data set in my geodatabase, where I right-clicking on it and going to that, I can give it a name. So I'll call it streams data, or streams. And it's going to ask me for the coordinate system of my streams data. Now, or of the feature data set in particular. And anything that I'm going to put into this folder, this feature data set in the future, needs to be in that coordinate system. It needs to match, or else it won't be allowed to be in that feature data set. So I'll leave that there for the XY coordinate system. It's asking me for a Z coordinate system. I'm not going to select one. The data I have won't have a Z coordinate system. And then it's asking me for XY tolerance, Z tolerance, M tolerance. I'm going to leave all of these at the defaults for now. I'll click Finish. And I get this little new icon named Streams here with an expansion item here, and nothing expands because there's nothing in it. This is a feature data set, and let's try to put something in it. So the NHD flowline data that I have, the streams information I have for California, is in that same coordinate system. It's in the NAD 1983 coordinate system that I just used, and it also doesn't have a Z coordinate system. But if I try to drag and drop it in here, it tells me the spatial references don't match. And it seems like they should, right? But according to it, they don't. So I'm going to instead right-click on it and go to Import Feature Class, and I will drag the NHD flow line over to the input features, and it's putting the output location as my streams feature dataset, and I'll call it NHD flow line NAD 1983, just to indicate that it's enforced to that coordinate system in there. If I tried to name it NHD flowline, it would probably conflict with what I have here already. The names need to be unique still. So if I click OK, it's going to start running and it's importing that data. It's converting that data across to a compatible format in that streams feature data set. So when I use the import tool there, or the feature class to feature class geoprocessing tool, which is what that was, it automatically handles any translations the data needs in order to be compatible with the feature data set, which is really nice. So when it's done, like it does with most geoprocessing tools, it starts adding it to my map for me, and I can see that I have it in here. So that's pretty cool. They're useful structures for using in your geodatabases to make sure that your data is using the same coordinate system in particular. The side benefit, as I said, is that you can use them as a sort of folders to classify your data. I could create multiple feature data sets that have different names but even the same coordinate system, so that they're both a constraint but also a way to classify my data. If I wanted to, I could also add the nav streams layer into that now, but we'll skip that. You just saw the process for it. But I want to point out that it can store multiple items. In enterprise geodatabases, where you're using a geodatabase server instead, feature datasets are also useful for managing permissions, so you could set permissions for who can access items in any given feature dataset. And then they're also useful for data sharing. That's one of the usages that Esri lists for them. One final thing I want to note about them before we move on is that if I right-click on them and go to New, note that I don't get the same options that I do if I right-click on the whole geodatabase and go to New. I have many more options, specifically for rasters and for toolboxes. That's because, again, it's a feature data set. It only handles feature data. It does not handle raster data. So I can't import my raster data into a feature data set. Okay, the next thing I want to point out is relationship classes. So let's remove this for now. And a relationship class is like making a relate in the map document where we do kind of that many-to-many join or that one-to-many join. except that it makes it permanent in the geodatabase. So if I right-click and create a new relationship class, I can give it a name of NHD attributes. And I'm going to do some of the same things just with different terminology than before, and with a little more power than we do when we do a standard relate in ArcMap document. And so our origin data is the data that we're trying to join to the feature class. So I have the NHD plus attributes that I want to join in. It's a data table of information I want to attach to my feature class. And then let's just use that streams data we just had. So I'll choose NHD flowline and I'll click next. So this is what we would do even in ArcMap. We'd choose the data that we're joining from and the data that we're joining to. And then we'll go next. And we have some options here. Basically, it's saying, are the data independent of each other? If I delete attributes in the NHD plus attributes, should I also delete the corresponding records in the feature class? In this case, we're going to say no, they're independent of each other, and we'll use the simple relationship. I'm going to breeze through this a little bit because there are so many options here, and mostly they're important in different situations. But know that relationship classes can make permanent relates, and that you should take a look at these options if you go to make a relationship class for yourself. So we'll leave the labels that it creates as the defaults. You'll see those when you go to switch between the tables in the ArcMap document. Well, I'll point that out in a moment. And then we won't propagate messages. We'll skip that for now. And in this case, it's a one-to-one relationship. So we could have actually done this with the straight join in ArcMap, but we're going to do it through a relationship class for now. And so it's a one-to-one relationship. We have one record in NHD plus attributes for every record in NHD flowline. And we're not going to add any additional attributes using the relationship class, so I'll leave it as no. And then here's where we select the fields that are common to the data sets. So these two use a field called component ID or COM ID. Then they both use that field. So I'm selecting that, and that's the field that is going to do the join on. And then I'll click next again. It gives me a summary, and I'll click finish to create the relationship class. And it thinks for a bit, and then it adds this item here, which is a relationship class, these arrows pointing between features here. Now, if I add the NHD flowline to my map document again, and I open up the attribute table, I will see the properties that we usually get through a relate. So if I select those there, and then go up here to the related tables, I can see those names that I was talking about earlier, where we could choose the directions of the names. And if I click that, it highlights the related fields for me here. So I could switch back and forth between the two tables this way. And note that I didn't have to go to joins and relates and then relate, and that I also can't remove the relate because it's not existing in the map document, it's existing in the geodatabase. It's permanent. So what's really great is if I send this geodatabase to anybody, it already has the relate inside of it. So that's a permanent relate. If I decided I didn't want it anymore though, I could right click on it and go to delete. Okay, now I want to show you geodatabase attachments. So we'll use our California counties layer for that instead. And I'm going to select Butte County because I have an attachment for it. And an attachment is a way for us to store other data that's not geographic data in our geodatabases attached to our features so that we can view them when we're working with the features. So we could add images, or we could add other information that just doesn't fit in the data tables for whatever reason. So to add attachments, I need to right click on the layer and go to Manage and then Create Attachments. And we see it adds a couple new things for us. It adds a data table with an attach suffix, and then it adds a relationship class, which we just learned about, that relates these two tables together. But that relationship class is going to do work in the background. We don't need to be too concerned about it. And then to work with attachments, I need to be editing the data. So I'll go to Editor and then Start Editing, which we should be getting familiar with now. It's going to warn me that the spatial reference doesn't match the data frame. That's okay. I'm not working with actual feature data here. And then I'm going to collapse that, and I need to bring up the attribute window that we have used before. And when I have a feature selected, I now get this attachments section at the top of the attributes up here. So if I make that stay here, and I'm going to collapse the catalog window for now, I can now click this down arrow and go to Open Attachment Manager. And I can now add and organize my attachments on this particular feature. So as I said, it's Butte County in California, and I have a picture that I want to add that's representative of Butte County to me for whatever work I'm doing. So I'm going to navigate to the folder and pasting it in the bottom and hitting enter, and it takes me to the folder. And then I have this buttecounty.jpg here. And so when I click OK, it's going to load that image into the database as an attachment to this feature. And so I'll click Save Edits, and it's all loaded in now. And now in Attachments, I can see it as a drop down here. What else is really cool is that we just glossed over the HTML pop-up in the past, but if I want to use an HTML pop-up to see the attributes on these features, on another feature it just shows the data table, but on one that has attachments, it shows us the attachments where it can. So this makes it a really great tool to explore and manage our data. And it also lets us keep all of our data for a project in one spot. It makes our geodatabase a true database where we store our data for a project. Also, now that our attachments are saved, I don't have to go back into the editing environment just to see the attachments. If I click on the layer in the attribute table, I can load the attachments from the right-click menu on the layer. So select the layer there, right-click on the edge, and go to Open Attachment Manager. And I can see those attachments there. And for items that get opened up in external programs, I can just click on them here and click Open. So anything that gets opened in a program on my computer, I can open it straight from there. So I don't just see it in the HTML pop-up. Okay, let's close out of this, and let's remove this from our map, and stop editing, and bring up the catalog window again. And the last thing I want to show you is compacting a geodatabase. So compacting takes all of the space that's been freed up in a geodatabase and actually clears it. So it saves space on your hard drive. And most geodatabases have this concept, but it works a little differently in each one. But know that if I was to delete something in my geodatabbase or shorten an attribute table significantly, it just marks those spots as free, but the space isn't necessarily freed on your hard drive. So if I right-click on my geodatabase and go to Administration, I can compact the database, and it runs a geoprocessing tool that handles this. I'll click OK, and down on the bottom it's running it, and it's freeing up the space on my hard drive and compacting the geodatabase into a single unit for me. Okay, that's it for this lesson. In this lesson, I showed you some core concepts of geodatabases that transcend different geodatabase types. So we talked about feature data sets, which you can use to ensure integrity of your data and specifically coordinate systems. I showed you about relationship classes, which you can use to make relates on your data permanent. I showed you attaching information to your data to make your geodatabases a true central spot for your data. And then I showed you how to compact your geodatabases in order to free up extra space. In the next lesson, I'll show you specifically about file geodatabases, and then we'll proceed from there to different storage environments. See you there.